Michael McDonough will be discussing a device that utilizes a sacrificial anode, which is eroded into a self-compressing plasma vortex to create a low-energy nuclear reaction. It's a type of fusion that can be used for energy generation. He'll be discussing the method of operation, test results from past experiments, and possible methods of propulsion based on this technology. So most of you probably aren't familiar with Michael McDonough. I've known Michael for probably 17 years now. He used to have a startup company that was working with a lot of these technologies. And so he is a wonderful and brilliant man. I'm so appreciative that Michael joined us. So Bernie, I'm going to put your hand down, and let me see. Michael, I think that we have you with us. I will spotlight you, sir. And
how's everyone?
Doing well, and thank you for joining us.
Do you have my slides ready, or do I need to do it, or?
What would you like to do it? Do you want to do it as a screen share?
I haven't actually used this type of interface before for that
Well,
purpose.
so what I would are you on a PC or iPad? Oh, Michael, you just muted yourself. Hold on just a moment.
Unmute. Okay.
Okay, yeah. You said you're on an iPad?
No, I'm on a cell phone.
Oh, okay. Yes, let me do that. Let me pull your slides down then. Yeah, the cell phone would not work for that.
It's kind of a one-trick pony cell phone anyway.
Yeah. Okay, so edited slides, and I'm gonna bring these down. Okay, so I haven't done this in a little while, but let me do this. I'm gonna share my screen. I'm gonna put it on Plasma Vortex Fusion. And hopefully, can you guys see this okay in Zoom?
I can see it. It's not perfect, but
you know what?
Seeable.
Here,
if you put it into what do you call it, mode? There you go.
Yeah, now it's full screen mode. Okay, so yeah, hopefully this is recording okay.
All right, I'm going to go ahead and just say it because you're recording it.
Yes,
this
sir.
is hydrogen plasma vortex induced light metal nucleonic reactor propulsion. In the system described, a hydrogen plasma vortex is created in a vacuum chamber as hydrogen gas is fed into it. The resulting pressure gradient of gas volume forms a suction head at the anode site, causing the metals to boil off and fuse, releasing energy and fusion-produced ions, which are drawn off and used. In this work, a nuclear chemical process is recreated from cosmogenic observations in the experimental device presented on slide 2. And the initiation of a hydrogen plasma vortex as it ablates the light metal anode under conditions of high voltage, low frequency, low temperature, a protium-containing non-equilibrium plasma, specifically a lithium, beryllium, and boron-containing magnesium aluminum anode is ablated. The reaction area is surrounded by an inductive coil, and added conductive elements are placed in order to shape the resulting E field to induce the vortex to compress at the anode site. As the gas and energy are released, the suction head moves about the anode, continuing the reaction until the anode is ablated and the fusion products move to the cathode. And you can go ahead and go to the second slide. All right, in the second slide here, as you can see, at the top, the silver cathode, it's what you see just at the very top of the center of that image. It's made out of like a silver coin in this particular instance, but it's shaped in kind of a vortex shape, which helps to create the initial vortex stream of energy to flow down the cylinder that you see here. And that hydrogen plasma vortex is what you see that is a kind of a violet color. That's the hydrogen plasma vortex. The reddish colored material around it, that's a solenoid wound coil that wraps around the vortex chamber, and that reacts to the plasma and generates an electrical current, which tends to squeeze the vortex down toward the anode. The anode at the bottom is where you see the bright flare on the arrow that shows as fusion. That is the light metal anode, and the important elements in it are the beryllium, boron, and lithium, which I'll explain later. In this particular prototype, which I still have in my possession, we're using it used a 20 kilovolt electrical transformer, like typical for a neon transformer, and it used a 60 cycle square wave input, and it was only using 40 watts. It was tested in a thermal bottle type of device, which looks for the amount of heat increase, and with a 40 watt 12 volt input, we were getting 280 watts of total heat energy output. So 7 times over unity for a 24-hour period while it was being run within the thermal chamber. Visible light energy was not tested, so it achieved 7 times over unity without even measuring the visible light that was produced by the plasma. So in my consideration, that generated nuclear level events within the plasma. Go ahead and go to the next. This is a WIPO patent image, World Intellectual Property Organization, of the plasma vortex chamber that you just saw in the previous slide. It basically just shows an outline of the elements that are involved, the coil in the center, and the anode and the cathode on either end of the tube, and his placement of the hydrogen bottle and all the other components of it. Go to the next slide. Next, yeah, there you go. This shows the plasma vortex flow schematic. In the top element, the hydrogen is induced into the reaction chamber. On the lower level, you see the plasma form between the cathode and the anode, and in this particular instance, the anode is hollow, which allows the gas to pass through. And this is just kind of a typical representation of a plasma vortex going through a tube. I just use that for demonstration purposes. Go to the next slide. The other direction, your other direction. Thank you, sir. This is the 3D layout of plasma vortex drive. This is my initial form, my preferred embodiment of the engine. On the left side of the screen, you see what is the injector site. This is the hollow sacrificial anode, which is shown in the colored area. The areas that are gray, those are basically made out of Maycore ceramic, which is it's as strong as steel, but it's a machinable ceramic, which I've already purchased. I intend to take the material that I have already invested in the initial prototype and split that down into 4 of these tubes, which will be designed to go into like a 6U type satellite, satellite configuration, so that we can test them in space. And I'll be looking for some funding for that. Go to the next slide. In this one, I'm showing what most people don't understand when they're looking at, say, for instance, a tornado, or in the case of this plasma vortex that you saw in the cylinder, is it's actually a toroid. When we look at a vortex, we see the vortex, but what you're actually seeing is the area that's down toward the center of this. And in the center, that area is what's visible on a tornado. And the same thing with the plasma vortex you saw in the tube. What you don't see is the outer part of the toroid. And in the bottle that you saw in the second image, that coil acts to flatten out and compress what is naturally this rather stretched out toroid shape, which is what you're actually looking at when you see a toroid, or in this instance a tornado. Go to the next slide. All right, in this slide, you see toward the left hydrogen and helium. This is the abundance curve of elements that in the observable universe. You see right after helium, lithium, beryllium, and boron. There's a deep dive down in the abundance curve. There's a reason for that. And Ari Degas, among other scientists, found out that the reason that there's this massive dip in the abundance curve is that all of these other elements that are in the second area that starts with carbon and nitrogen and oxygen, those are formed in the toroidal vortexes that surround the star. Stars are formed by helium and hydrogen being compressed into lithium, beryllium, and boron. The lithium, beryllium, and boron, actually, as it is formed in the star, form at a much lower energy level in the corona of the star, in the vortex filaments that surround the coronosphere of the star. All of them that you see from basically from carbon to nickel and copper, those are the ones that are produced in the toroidal vortexes in the surrounding area of a star, and also in every other sort of vortex type of plasma filament in the universe that generates all of the heavier elements. So what Ari Degas has discovered, and what we're going to be utilizing for star drives eventually, is being able to use that low energy nuclear reaction of lithium, beryllium, and boron, and forms the heavier elements that are on the periodic table to power our star drives. And because of the Schwarzschild, what do you call it? The right term. The
Schwarzschild radius or metric?
No, not the metric. The Megas effect. There's a Schwarzschild Megas effect. The Megas effect is what causes the low energy nuclear reactions. The spinning of the vortex, the apex of the vortex, where it strikes the elements that are being fused, that vortex, that compressed area, there's a Schwarzschild Megas effect at the rim of the vortex, and that's what causes the low energy nuclear reactions. It's because you've got all of the electrons on one side, all of the protons on the other side, and they're flattened out at a extreme angle at that place, and that creates a collapse in the Coulomb barrier, which is why you're able to have these low energy nuclear reactions at amounts of energy that are unexpected. When we look at fusion reactions, we're looking at helium reactions, or helium hydrogen, or one of these, helium hydrogen lithium, the very low end. Those reactions actually require a lot more energy than beryllium and boron. The lithium is a little bit less, but the beryllium is the lowest, and the boron is the next to the lowest as far as the amount of energy that is required for it to fuse into the heavier elements on the periodic table. Go to the next slide. On this one, I'm just basically showing that and I did change that powerful to 1L anyway. the vortex is the most powerful force in the universe. Everything that all matter is formed in vortexes. Photon geometry demonstrates vortexes. All atomic structure are toroidal shape. Everything in the universe is a toroid. You know, everything down to the atomic level, all the way out to the universe, and everything in between. And that's my presentation.
Okay. So let me do this then. Let me stop sharing. Okay, and so actually that was really fast, Michael, but thank you.